So, unleashing serverless scalability on AWS, that sounds very ominous, doesn't it? What do I mean by scalability? I'm going to define that first, because for me, scalability on AWS and serverless is all about maximizing your transactions, your throughput of your system, while minimizing your concurrency. When we do serverless systems, no matter where you are, it's all about concurrency, and it's all about controlling that concurrency, and seeing a few people nod in the room. So I've got an interesting story to tell, which would be really interesting. But to do this, you need to focus on controlling that. We always learn the most the first time we do something. The first time we ever do something is where we learn everything. I'm going back to the first system that I ever produced on serverless. And I'm going to talk about that. It's the foundation of everything I do today, and everything I learn, and everything I speak about today, and everything I teach people about serverless today. My name is Michael Walmsley. I've been building software for over 30 years. Just before the break, there was a panel, and there was a bit of a talk on the panel from people about changing careers and being new, and what are the challenges they overcome. And there was a feeling of a few people on the panel there that have been new. Susanna said she's only been doing IT for 3 years, and she struggles every day to learn things. I've been in the tech industry for 30 years, building software for over 30 years. And every day, I'm learning something new. Every day, I feel exactly the same way. That's Susanna, and even Tim, who mentioned that. So anybody in the room, when you're thinking about, gee, that's hard, think back. People are doing this a long time. We're still learning. 30 years ago, there was no cloud. There was no microservices. When I started, there was no object-oriented programming. I had to learn it all myself. But I've digressed a little bit. But I think that's an important digression for a community conference like this. Yes, I'm a lead architect at Accenture in Melbourne, in Australia. I work globally. I don't do consulting. Everyone goes, you don't do consulting? That's true. I work on an inwardly focused product group within Accenture. We build products that go out to all of our customers globally. So I work in managed service contract areas within Accenture, pushing out products to Fortune 500 companies of the world. I'm a specialist in AWS and serverless technology. I co-host the AWS Programming Tools Meetup in Melbourne. We do a 2-hour workshop, hands-on, every month. And anybody can come along and teach. Next month in June, I'm actually running it. If you happen to be in Melbourne, come along. I'm going to be going through Power Tools. So what you saw AWS do earlier today, I'm going to run a workshop exactly on Power Tools. I've been a contributor to Power Tools for the last 4 years and worked very closely with the team. Also building serverlessdna.com, that's where I do a lot of blogging, so check it out. And last year in July, I was recognized by AWS as a serverless hero. Thank you. I'm humbled. All right, what are we going to talk about? We're going to talk about my journey to serverless. I think it's really important that we talk about our journeys. I'm going to spend a lot of time talking about when it all goes wrong, because it's when it all goes wrong that we all learn the most. So I'm going to talk about a particular project where it did go wrong, and it was all my fault, and I learned a heck of a lot really quickly. I'm going to talk a little bit about serverless patterns, referencing back to Sheen Bristol's talk earlier this morning. I'm going to talk about what I call blueprints for success. And once we get to that point, it will all start making sense with the story we're going through. And then we're going to finish up with key strategies for unleashing your serverless scalability. Let's get going. I started my journey. We got any tennis fans in the room? We've got 1, 2, 3. I actually started, the first serverless system I ever built was for the Australian Open. I started building that in 2018. I re-architected the serverless backend for live scoring for the Australian Open digital experience. So anyone who's downloaded the app or used the website, when those little numbers on the scorecards change, I do that. That was me. That was me. When the little tennis ball changes, when the serve changes, that was me. I did that. I actually worked out the algorithm for that, including all the rules for all the other things. I learned a lot about tennis rules that day. And that's really when my serverless journey really kicked in. That's the first thing I ever built and delivered to production back then. And it was all very raw and ready back then, more so than now. So data processing scale. I'm going to talk a little bit about scale, because scale is really important. In serverless, it's all that's really important, I think. It's the most critical thing we all need to focus on. And I always do focus on it. For the Australian Open, there's 2 levels. 2 levels, it's working now. 2 levels of scale. You've got the back-end scale, We have thousands of events. It starts maximum. So day 0, you got maximum throughput. And it slowly scales down and scales up. It scales up a little bit because we've got events, new events coming in. But generally, it starts high and just drops off really slowly. The red line is front end. So I was responsible not just for delivering processing the scores that came in from all the courts live. I think we had, on average, a 4-second delay between the umpire making the call and the digital experience being updated. We're quite proud of that, to be honest. I thought it was pretty cool. And serverless made that happen really, really quickly. It was really cool to watch that scale. I fell in love with Lambda watching it scale through this project. The front-end scale is completely different. It's pretty much like any other digital experience. It starts off really low and then just goes up to millions of users. And of course, there's also those viral events when things go super crazy. And then you have to be really ready for that. So those viral spikes when two champions are playing and the underdog is winning, all of a sudden, unexpectedly, the traffic goes through the roof. What did we build? High-level architecture. I just want to give you a view of the high-level architecture. Going back to what Sheen Brussels were talking about earlier this morning, he really referenced being able to talk about set pieces. And really what we've got across the top is real-time score processing, which is completely isolated in that purple box from the front-end experience, which is down the bottom, which is in that green box, which is all about front-end APIs and scores to front-end. Totally segregated, and for a really, really good reason. We wanted to make sure that our database is storing the score data is not overrun by the front-end, because front-end actually has the potential of unlimited users. And when you're dealing with a viral sporting event that goes for 2 weeks, unlimited users happens, and it happens regularly. So you need to be ready. You need to be really ready, and maybe have a bit of luck. So today we're really going to focus on the 2 entry points, these 2 big red arrows. That's where all the data comes from. That's where all the scale comes from. Real-time score processing is relatively simple, believe it or not. It sounds really complicated. At the end of the day, I'm just changing numbers on a website. That's what I keep saying. There's a whole lot more to that, but that's effectively what happens. So at the top, we've got an event broker or messaging pattern. So Sheen Brussels talked about breaking down complex problems, and that's exactly what we did with this build. This is the first time I ever built in serverless, and there wasn't as much community content around serverless back in 2018 when I was learning this. And it was really hard to learn. I actually consumed a lot of content. There's a lot of trial and error in what I learned through this project. Classic event broker pattern across the top. And down the bottom, from the message processes, they have to communicate to an Aurora RDS. Yes, I could have used DynamoDB. Aurora already existed in the previous system. DynamoDB back in 2018 didn't have the levers it has today. It doesn't have the convenience it has today. You had to know what your read and write units were, and if you got them wrong, AWS charged you extra, a lot extra. So it seemed to me like it could actually cost a bomb if I got that wrong, and I was really worried. Learning about AWS, learning about serverless, building a live score system for one of the biggest sporting events on the planet. No pressure. So we used the command. I built it in the command pattern. Very classic command pattern. Basically, message processes will push down events into a SQS queue, and the update for the score database would just read those events and push those in at a calm level, making sure that the Aurora database doesn't get overrun. Very classic serverless patterns that I put together. Very common. And it's all event-driven, so that's why the event broker. Front score API, live score, front-end code. This is unbounded. It's unlimited. You have no limits. So we work with a lot of partners, and it's all about caching. Success with live sporting events that go viral is all about caching. So I made a choice that we've got our back-end processing, we've got our front-end processing, we've got pushing data to a CMS to update all the matches and draws. We've got data coming through, being pushed into a Redis cache. I chose Redis because I was worried about Dynamo, as you know, so I chose Redis. Solid choice, super fast, low latency. Quite expensive because you've got to scale that. And as Tim would know from earlier, that really when you're dealing with front end and you really want to make sure it works, what do we do as technologists? We overscale, don't we? We do. But basically, we've got Lambda caching, reading from the cache, that's caching. We've got API gateway, and we've got a CDN cache globally being cached as well. So it's caches everywhere, and it's caches back into the front end. So everything's caching, which is beautiful. But it's a serverless system, And we've got this little ElastiCache sitting here. And we know that ElastiCache is the connection bound resource. So during my experience on working on the Open, we were preparing. I had approximately 8 weeks to build most of the system, to get most of it working for a really tight schedule of going into solid performance testing, solid QA, for a shutdown for the beginning of December, and basically code freeze for a month before the Open actually started. So we had to work really quickly. I was the only serverless dev on this project. We hired somebody to help with support in around the November timeframe. So I was using ElastiCache, and just before one of these performance tests, I got everything ready, everything was set, but I forgot to scale the Redis cache. So let's have a look at what happens when it all goes wrong. Anyone who knows me loves it, but everyone knows that I love talking about when it all goes wrong. This is an image that I generated with Midjourney about for one of my blog articles, also about when it all goes wrong. So really nice and simple. We've got front ends coming in, front end's hitting it, our back end's processing, our front end's coming in, getting higher and higher load. Low volumes, it's fine. Then Lambda starts scaling up. We've got higher volume requests coming in. And all of a sudden, we get more connections going into that little Redis cache. And then, till it gets to the point where there's too many connections. And of course, this is when things start to go a little pear-shaped with serverless. These are the stories you hear when people go, serverless sucks. Serverless doesn't work. Serverless is dangerous. It costs too much. What's going on the other side? On the other side of this is we're also updating the scores at the same time. So they're also trying to connect to Redis. And they're also slowly building up. And all of a sudden, I feel like it's like a Cowboys indie movie, or it's somebody being surrounded. But anyway, I'm losing my train of thought. What are we talking about here? What I'm talking about here is, I really want to focus on here right now, this point. This is what I call a scalability boundary. And it's something that's critical as software engineers and architects that we understand what scalability boundaries are. And in a nutshell, it's where we have high scale on one side, AWS Lambda, clashing with something that's lower scale. In this case, Redis with limited number of connections. And that's something we all need to be looking out for, because these are the things we need to identify early, protect, and design for when we're thinking about doing serverless implementations for anything. And they exist in a whole lot of places. So what happens when scalability boundaries collide? Well, you've got your AWS Lambda, where everything works beautifully, connecting to Redis takes a couple of milliseconds, super fast. Connections might already be open, super duper fast. We had a live score Lambdas sitting at a VPC in 2018, delivering live scores back to a front end in under 4 to 5 milliseconds, about 4 to 5 milliseconds, 6 milliseconds. It was super fast, which is awesome, really awesome. Except ElastiCache is busy. And when it gets busy, has anyone in the room ever experienced when a server gets overloaded? Has anyone had that experience? Yeah? Things just slow down. You don't understand why. And this is classic in other areas as well. I've worked in other cases where a company I work for dealt with Sitecore, and they did that on Azure, and they had Azure functions talking to a cache on Azure. And the tech lead comes to me and he goes, I don't know what's going on. I can't make sense of this. My Azure functions, they're all just timing out, but some of the data is getting through, so it's working. And I went, your cache is not big enough. You need to scale it. And he goes, no, that's not it. There's got to be a code problem. I said, it's your cache. Because what's happening here is Lambda's going in and building up into your Redis cache. The poor thing is just trying to service new connections. It's got no memory left. The CPU is throttling and swapping. And what happens is your duration just goes up in your Lambda. And when your duration of your Lambda increases, Redis is more under load. And as your Lambdas take longer to execute, the concurrency across your entire account is growing. And it's going to start growing exponentially at this point. You can see where this is going, right? Has anyone experienced this? A few people? Yeah. You know, you all know what I'm talking about. Everyone else, you just need to And when eventually you get to a point, because the lambda duration is increasing, your overall concurrency is approaching max. And when it approaches max, we get throttled. AWS has a mechanism that just throttles the executions. So now you've got a lambda being throttled. But remember, we've got just not one lambda. We've got about 5 or 6 lambdas in the system. This is at the account level. So this throttling is not just the one lambda, but it's all of them. You look at that and you go, when this was going on, I was looking at this, and I was looking at this problem, and all of a sudden I saw the concurrency going up. I'm like, what's going on? I didn't realize at this time that Redis hadn't been upscaled, and it's like that was the problem. And we looked at where the problems were occurring, and obviously the higher concurrency was hitting on a few particular lambdas talking to Redis. And I'm going, what's going on with Redis cache? The QA on the job at this moment, when the performance test is running, shouts out and goes, hey, Michael, I just noticed the scores on a match go backwards. And I'm like, so the system's still working and functioning, but it's not functioning properly. And I'm like, what the heck? Lucky, this is a test. This is not live. This is not while the open's on. So right now, at this point, you have no idea what's going on. In most cases, in my experience, you'll end up having some sort of program manager or tech manager suddenly go, oh my God, the AWS account is at limit, concurrency limit. I don't have enough concurrency to run the rest of the system. So they panic dial their AWS rep, get on the phone, and all of a sudden your account goes from 2,000 concurrency to 10,000 concurrency. And the guy goes, I've solved it. We've got 10,000 concurrency. Wrong answer. It's out of control. Redis hasn't been solved. The problem's not solved. Now, instead of maxing out with 2,000 lambdas, you've maxed out with 10,000 lambdas, and it's just cost you more money. 5 times more money. So don't go and do that. So what can we do? What can we do when all goes wrong like this? We can deactivate the lambda trigger. We can try and stop transactions entering the system by using a control point. And quite frankly, you should know your expected volumes. Obviously, performance test before release is a key one. Examples of scalability boundaries is connection limited resources like Redis, OAuth endpoints. If you've got an external OAuth endpoint anywhere, that's dangerous as well. That's going to, anything external. Rate limited APIs, external integration points, they all factor in. I want to talk briefly about serverless patterns. Because the best thing about serverless is it's easy to get started. It's easy to get started because we can go to places like serverlessland.com. You can find a whole lot of patterns on serverlessland. Who knows about serverlessland.com? If you don't, go check it out. There's great patterns on there, great patterns. Even whole solutions. So it's a great place to start your serverless journey. You can pick things up and you can use them. Highly recommend it. The worst thing about serverless is it's easy to get started. I didn't coin this frame, I've actually stolen it. I think Lee James Gilmore coined this first. I read that a few years ago, and I thought it was great. I think it sums up serverless really, really well. So be warned. So I want to talk briefly about, I want to sort of finish this off with talking about, and this clicker is really, really taking a lot of clicks, about blueprints for success. So we talked about patterns. She and Bristles this morning also talked about patterns. And really when we talk about patterns, we're talking about taking those things from serverlessland.com, but not just dropping them straight into your projects, right? How many people do that? Just drop them straight into your projects. I think a lot of people do, right? These are not production ready. They're not blueprints yet, they're patterns. And I really want to make the distinction that what you should be doing with those patterns is taking them and turning them into a blueprint. You can do that by looking at scalability boundaries. We've got an external service, that's a scalability boundary. Number one, always look for scalability boundaries, because they're the things that are going to bite you and kill your system with concurrency. So we can protect that. We can introduce an SQS queue. Now we're changing the pattern. We're turning it into a blueprint, something we can deploy and operate reliably. So we can talk about event source mapping briefly. Go and look that up. It's great. It's a key way of controlling the way you scale your Lambda. The event source mapping has a lot of levers and controls. Don't ignore them. Dig into the levers and controls of all the services you use. That gives us instant flow control, which is great. And also, we can introduce a dead letter queue. And introducing a dead letter queue, now we have a control point. A control point, if something goes wrong with the external service, we now have a control point, an operational control point, that anybody who operates the system knows they can deactivate a trigger and stop it going wrong, or stop it from interacting with a service that's struggling, but still queue up the transactions without affecting our front end. So we can keep our system running while there's a problem. Control points are really, really important. And at the end, we end up with a complete, we've looked at the scalability boundaries, flow control, control points, we've got a dead letter queue. We understand our transaction volumes. Now you've got something that becomes a blueprint. Overlaying on top of this is all the other things you need to do as a responsible citizen, all your security and all the other things that you need to do to make that real and make that safe to run and operate. So, unleashing serverless scalability. Control your Lambda concurrency is my number one piece of advice. Control that. This clicker is really... Protect scalability boundaries. Design for control points so you can actually operate your systems and keep them operating smoothly. Configuring flow control. Turning patterns into blueprints. Understanding service configuration levers. And I kept adding things last night, and performance test everything. Number one key thing, always performance test before you go live. Most important thing. If you don't do that today, I think you should do it. It's really easy. There's a lot of good tools out there. Thank you. Here's to unleashing serverless scalability. My name is Michael Walmsley. You can find me on LinkedIn, GitHub, at Walmsley, all the normal places, and serverlessdna.com. Thank you.
All right. Thank you, Michael. What? What did I do? Oh, yeah. Nah. No, I like blinding people. I thought I'd give you... It is Friday afternoon, right? So we got to get... Oh, there's a hand. Hi.
I missed what exactly with the caching what part.
So caching was more for the live experience. It's when you have front ends, it's unbounded connections. So caching is super important. That's why there's layers of caching. And with a live scoring event like the Australian Open, the CDN cache is super important. It was set up in such a way that actually I think 85% of all of our traffic was served directly from cache. There was only new pops coming up as different countries or regions came online that we really had higher peaks of volume over the API. But serving that up with an inner cache within the Lambda environment also protected all the Redis resource when it was rightly sized.
The resource of caching is a
Caching was just so you don't use the resources, so you're not hitting those live resources. So
how do you solve the problem?
Yeah.
Did you increase?
In this case, I had to in this particular case, sorry, I did mean to come back to that. Sorry. In this particular instance, the Redis case, we just had to upscale that to enough nodes, horizontally scale and vertically scale the nodes enough to cover the peak volumes.
Other question. I'm just a developer who expect $30 and when it goes up to $150 I was panicked. What kind of cost is the third application? Just a rough reminder.
For Australian Open, Redis alone was probably about $5,000 for 2 weeks. But a Lambda cost, I think a Lambda cost was about $12, $20. Would have been under $100 for Lambda.
So it's not like it's like under $1,000.
I don't have the exact figures. I didn't have that sort of account access. So, but let's catch up in the hallway, talk more. And maybe, did you scan that QR code to get some credits?
They have been scanned.
I can show it to you later. I've got it on my laptop.
Yeah, we got to get on to the next. Good questions, though. Also, because this jacket is unbelievably warm.
It's warm up here.